Here goes nothing. All right, so anyway, so number 13 says, consider the relationship between the number of bids an item on eBay receives and the item selling price. The following is a sample of 10 items sold through auctions on eBay. All right, so we're going to work through this problem and put everything in the calculator and get your calculator set up. Currently, your calculator is not set up to do the R. I'm going to show you how to get your calculator set up for R. Okay, so if you have a 84 plus, it depends on, I'm not even gonna start throwing out numbers, but depending on your calculator, you may have it in the shortcut. If you don't have it in the shortcut, then I'll show you how to do it the long way. All right, so in the shortcut, if you go to, well, I'm gonna do it the long way because that's the way I know right off the top of my head. If you go to second and then 0, right? If you hit second and then 0, that's catalog. So it brings up all of these different things in your calculator that you probably didn't know even existed. All right. Now what you would do is you would scroll down and you can probably put in the letter D to diagnostic on. All right. So you can scroll down on your calculator till you see diagnostic on. All right. So scroll down there. Now everybody's calculator can do it this way, so this is the way that I'm showing it for now. You hit enter next to on, not off. All right, and then you hit enter, and then it'll just say done. All right, and so it means that it's on. So what happens to most people, so in case something happens and you have to reset your calculator, that was you, right? That said something about resetting your calculator all the time. If I reset my calculator, and I'm going to, reset my calculator, then it won't be on. So if you take the batteries out or something happens, it won't be on. That's how you turn it on. And then I'll show you how to turn it on the quick way. The quick way is if you have a newer calculator, you hit the mode button. Now, if this pops up for you, that means that your calculator is the newer calculator with the newer upgrade. If it doesn't, then it means it's not. All right, but if you hit the mode button, right? And you see down there it says stat diagnostic, all right, and then you can have it on or off. So either one of those ways will turn this function on, all right? All right. For now, I'm going to turn mine off and show you what happens when it's off, all right, because that's how you started with it, all right? So let's go back to our data. So we're going to go back to our data and I'm going to give you a minute to put in these. So we already talked about how to input data. So you put this in, we go to stat and then we go to edit and you're going to put the first line in line 1 and the second one in line 2. All right, and I'll give you a chance to do that because I can't switch. I can make it smaller, but I currently don't know how.
Is there a way to like delete like all of these?
Yes, oh, that's a good question, actually. Let me go over that real quick.
Because I'm gonna be honest, I kept clearing my calculator last night.
Yeah, I want to go over that actually. So the question was, can she delete the ones that are in there? So let me go to stat. I should have something in there and edit, right? So I got these in there from the last class to delete, and never hit delete when you're in here because you'll delete the whole L1. You can get it back, but don't do it. So if you go up to L1 and you just hit clear and then enter, it'll clear out the whole line. Okay. All right. And then you can start inputting all of those numbers. Okay, so we got the numbers in, and again, hopefully you make sure that you have the numbers in correctly, because there's nothing that I can do, nothing that anyone can do if your answer is incorrect because you got the numbers wrong. So double check, triple check. It's one of those things I think they say, you know, measure twice and cut once. Yes, you specifically go through and make sure you got all the numbers in correctly. Do that a couple times before you go to the next steps, because the next steps are pretty easy, so you don't have to worry about anything being wrong. So real quick, I'm gonna have you make a scattered plot in the calculator. Now, sometimes you may or may not use it, so we'll see, but the book has you make a scatter plot. Because the only way that the Pearson correlation coefficient works is if it's a linear relationship. Let me repeat that. If it's a linear relationship, that's when you can use the Pearson correlation coefficient. If it is not a linear relationship, you cannot use it. You cannot use what we're about to do. So you have to know if there's a linear relationship before you do all of this. So hence, that's why they have you draw the scatter plot. Because if you draw the scatter plot and you see, like we did in the notes, the nonlinear one, then you're done. No, you can't do it, you can't work with it, because the Pearson correlation coefficient only measures linear relationships. If you don't have a linear relationship, you can't use this. You won't get into what else we'll be able to use. That's beyond the scope of this class. All right, so let's get ready to go in and move this over. Let's get ready to go in and figure out how we're going to do this scatter plot. All right, so to get out of anywhere that you're in, you want to hit second and then the button next to it. Don't ever hit anything while you're in these numbers, while you're in this place, because again, you might tap a number, and once you tap a number, it's all over. So just hit second and the button next to it, which is mode, and on top of that is quit. So second and mode. You always get out before you start any new steps. The next place you want to go to do this scatter plot is you want to go to second, and you want to go to the Y equals button, which is stat plot. So hit second and then hit stat plot. All right. Right now, you should be able to see that my stat plot number 1, don't worry about the rest of them, is off, and I'm going to turn it on. Yours should be off if you haven't loaned your little brother or sister your calculator or something like that. All right. So it's off. Hit enter. And then now you see that it's darkened on off. I'm going to darken it on to turn it on. Don't touch nothing else. If you want to know, the type is where it should be, because that's a scatter plot. L1 and L2 is where your data is, if you remember. You put stuff in line 1, you put stuff in line 2, so it's already there. Don't touch it. So if we want to get out somebody, how do we get out of here so we don't touch anything?
Second mode.
Second mode, all right? That's how we get out. So second mode. All right.
What was when we turned the second 0 diagnostic on, what was that turning on? Like
Turning on the turning on the correlation coefficient. And when I do this, you see that I won't have one.
Okay.
So it will be clear in a second. All right. So the next thing you want to do after you've made sure, and this is going to be on, this stat plot is going to be on until you turn it off, and you probably won't in this class. You're going to hit the graph button. Now, when you hit the graph button, you won't see anything yet. All right. So because it's not graphing, it's graphing, but you don't see it. So then you have to hit zoom. And then what class are we in? Stat. So zoom stat, that's number 9. You can either scroll down or hit the number 9. I'm just going to hit the number 9. And now you should see these points. If you don't see these points, people in Zoom say something. If you if you don't see these points, then something's wrong.
Okay, I was trying to write and do this.
That's fine.
So what did you do after you said graph, zoom?
Oh yeah, graph, and then zoom. And then if you ever forget, think of the class you in. Stat.
Okay.
Yeah, hit number 9, and you should get that. Actually, the other thing I want to see is, did I put all my numbers right? Is this the graph? Does your graph look like my graph? Everybody, does your graph look like my graph?
Yes.
Yes.
All right, the points should be, yeah, they should be there. All right, so let's wait for a second. Yeah, so the point should be, you know, around here or whatever, all right? So if you don't see this, then that means you put some numbers in wrong. All right, you put some numbers in wrong, that's all, that's the only thing it is. Not the only thing it is, but it means you put some numbers in wrong, okay? So your graph should look like this. So our question becomes, if we look at the directions back in the textbook, all right? It says draw a scatter plot, check, you've done that. B, estimate the correlation in words that is positive, negative, or no correlation. All right, so let's take a look at that. Somebody got any idea on this one?
Kind of spread out, but I mean, it's going up, so I guess I'd say positive.
Yeah, it's positive. So you I know you're like, yeah, and this actually probably going to be weak, but positive. They're going up. They look that way. Now I can make it like zoom in and try and make it a little bit different, but it's pretty much positive. Put it like this, if it's no correlation, then you'll see it. It'll really be like more scattered out or something. So it won't look positive, and then I say, oh, that was a no correlation. Nobody's trying to trick you. So this is pretty much positive. If you can draw a line like this, and all the points are not gonna be on it, but they're gonna be going in that direction and then surround. So this is a positive relationship. Anybody in Zoom land got any questions? Savannah, you got any questions on how this is positive?
No, I got it.
All right, positive. Now the next thing in our textbook says to calculate the correlation coefficient, right? Calculate the correlation coefficient, which is R, all right? So let's do that. So to calculate your correlation coefficient, all right, we're going to get what's known as our y equals mx plus b, which you'll actually use in 12.2. So that's what we'll be doing, all right? So we're going to go to what class we're in. We can go right to stat, all right? Over to calculate. Now, there are two, line regression. There's line regression for algebra, which is number 4. You see is ax plus b or mx plus b. Then there's number 8, which is for stat, which is a plus bx. They actually give you the same answer. The a's and the b's are just variables. But in statistics, you want to write it a different way. So whereas in algebra, you write your intercept last, in statistics, you write your intercept first. But it's the same flipping thing, all right? So I'm gonna always say you're gonna go to number 8. If somebody make a mistake and go to number 4, it's not gonna give you a different answer. You're just gonna be, have to write it the proper way. So I'm gonna hit number 8, linear regression, right? And if you have the newer 84, you'll get this screen. If you have an older 84 or an 83, then you won't get this screen, all right? If you don't get this screen, then hit enter and you should be good. If you get this screen, then enter, and then all the way down and hit enter, and you'll get this. So if you look at my screen, I'm missing something. So Rachel asked me, hey, you know, what did we turn on? Everybody see, I'm missing the R. I mean, it gives me this y equals a plus bx, which we'll use in a second in 12.2, but it's not giving me the R. So y'all got the same thing?
Yeah.
Yeah.
On your screen?
We already turned off.
Yeah, yours is on. Remember, I turned mine off.
I was like.
No. I turned mine off because I wanted to show you to answer your question.
Right. Okay.
That's what that on is for. So the question was about me missing the R. I did that on purpose. So now I'm going to turn it on. I'm going to go to mode, and you see I'm going to go down to, I'm doing it the shortcut way. Go down to stat diagnostic, and I'm going to turn it on. And then see, I need to get out of the screen. I don't want to touch anything else. I'm going to do my normal second mode. And now I'm going to go back and calculate that. And this time, number 9. Oops, no, number 8. All right. So this time, now you see my R. Everybody cool? All right. So that's what happens when it's not on. So, but we have our R. So the question said, calculate the correlation coefficient for R, and that's going to be R is equal to 0.693. Everybody cool? If you did not get this in Zoom land, please say something so that I know that you know what's going on.
Yeah, I got that.
All right, so 0.693. In the next section, is it the next section? Or is it this section? Yeah, not this section. In the next section, we'll talk about R squared. That's something. So that'll be in this next section in 12.2. We'll talk about R squared because we'll use that also. And R squared is one of the things that you'll have a percent. So that's it for figuring out the correlation coefficient. All right. The last question in this talks about statistical significance. All right. Talks about statistically significant. Is this statistically significant? Now, anything that you find in the calculator is done from let me go back from stuff here. All right. So anything that you get in the calculator is done from a formula. Obviously, somebody programmed the formula and put it in there. All right. As opposed to something that you get from the charts that we'll be working with here in statistics, we're going to have about 5 charts that you'll be using during statistics. So when we get something from a formula, all right, we call that, we have a name for that that's different than when we get something from a chart. So I'm going through that because in the book it says R, alpha R, somebody had asked me earlier about why it says it's the absolute value of R is less than or equal to R alpha, I believe is the terminology in this textbook. I always get my textbooks confused, all right? Yeah, give me 1 second. Double check for this textbook. But anyway, either way, it doesn't matter. So we have a critical value that we work with, and we work with those from a chart, and then our other value is our statistical value, or our value that we get from the calculator or from the formula. So in this case, we had R was equal to, what you say R was equal to?
0.693.
0.693. All right. So in this one, we had R is equal to 0.693. All right. So this is the one that we got from the calculator. All right. And then we have what's known as our critical values, which we get from a chart. All right. So critical values are values that we get from some chart. All right. So we need to compare this 0.693 to something to determine if it's significant. So what do we mean by significant? This is the important part. So when we're in statistics, we're trying to figure out, okay, is this statistically significant or not? Well, what the hell does that mean? Well, that means everything has a relationship. You can find a relationship in anything. You can find a relationship in this marker and the board, all right? It can have a relationship, all right? But is it significant? Is it significant enough that statisticians want to do something with it? That's basically it. Remember last class I told you about the correlation between socioeconomic status and teen pregnancy, all right? So if the relationship was low, then nobody wants to study it, okay? So it's not statistically significant. So if the relationship is low, nobody wants to study it. It's just something that's going by, like today and the color of your outfit, all right? So nobody wants to study it. But if it's statistically significant, it's something that somebody wants to study. So that's why we need to know, is this 0.693? Yeah, we know it's, I would call that a weak positive, definitely. All right, it's weak because remember, if it was strong, it would be closer to 1. Now you see this is way close, way off, away from 1. All right, so this is definitely a weak positive if somebody wanted to know. All right. But it's weak positive, but it's a statistically significant? Is it something that we want to research? Is it something that we want to take a look at? Do we want to do anything with it? So that's why we need critical values that come from a chart. These charts were made back way back ancient Greek, Rome, I don't know, way back in the day when I say the mathematicians didn't have a life. So they sat down and created all this chart and created algebra and geometry and all this math because they had nothing better to do but to, at that time, ignore their wives, right? So, so they did. They went in that little room, nobody found their husbands, and they're down there doing math like Ramanujan. Most of the mathematicians didn't even get married. And if they did and they were like Indian, then they paid no attention to their other halves, which were obviously same sex back then. Maybe they weren't, they just was in the closet. So go ahead.
Is there, what would, I'm just confused on what negative would be like. What would the number be if it was like weak negative?
Oh.
Oh. Well, then wouldn't it be weak if it's like under 0.5 and then strong if it's above 0.5?
No, that's not strong enough. That's a good question. So, no. It would be weak if it's 0.888.
Oh.
It has to be really close to 1.
So most of the time it's gonna be weak.
No. You'll get a lot of the strong ones. This one just happens to be weak. I don't know about the textbook when we go over another one, but no. Not most of the time it'll be weak. It's pretty strong. Like height and shoe size. I think that's one of the that might be one of the homework questions. That's a strong positive. Like the taller you are, the bigger your feet are. So that's definitely a strong positive, and it's there. So no, there are a lot of things that are strong positive. That's actually a good question. All right. And he said, what would it look like if a negative came out? It would literally come out with a negative. So this could have been a weak negative, just having a negative, but it's not close to -1. All right. Good question. All right. So these critical values that come from this chart is going to tell us, okay, is this statistically significant? Does this -0.693 mean anything? So we're going to flip over and start to look at the chart in a minute. Okay, so we left off at the R value here being 0.693. For it, I clicked on the notes in chapter 12. If you go there, you get chapter 12. We are going to go over R squared because it's actually listed in 12.1 in a minute. So let's get back to this correlation coefficient chart. So I need to share my screen again, locate everything.
Okay, this is a really random question, but like, what's like the closest gas station? Because I
I'll tell you when we're not recording.
Oh, sorry.
Don't worry about it, it's for y'all anyway. So we got our equals 0.693 for our R value, and we get critical values from the chart. So this is going to determine the significance level. So the next question is going to ask you to determine the significance level on the quiz or on my exam. Not significance level, determine the significance. Let's go determine statistical significance. That would be more like the question.
Could I just add that to like you know how you're numbering the different.
Yeah, what number are we on, by the way?
8, I think, right?
What'd you say?
I think 8.
I wasn't labeling numbers. I was just.
Okay.
writing down.
So determine statistical significance is a thing, and what does that mean? The question is going to be, is this statistically significant? That's all the question is going to be. Is this statistically significant? And to determine if it's statistically significant, your R that you just got, or the absolute value of R. Anybody remember what absolute value means?
It's like.
It's the bars, and what does it do? So what's the absolute value of 5? Anybody Zoom land? 5?
5.
5, yes. What's the absolute value of -5, Tia?
5.
So the absolute value makes anything positive, or in the first question, keeps it positive. So it's R, so that would go back with Trevor's question. If this was negative, then we still would wind up with positive. So something is statistically significant if the absolute value of this R is greater than or equal to what we're calling R alpha, all right? R alpha is the R that you get from the chart, all right? Alpha, that little curl thing, all right, that we'll go into, alpha is the significance level, the level of significance. So let's put that would be number 8. I know your number's off now, Trevor. Alpha is the level of significance. All right. Right. So that's what those two things represent. So we're going to, and I'm going back to the example in our book. All right. So we're going to look at the chart. So as you see here, you see alpha up there. You see all alpha. Alpha 0.01, 0.05. We'll talk about that more when we get into more about statistics later in the chapters. Go ahead.
What did you say that little like thing over the alpha symbol means? The little like half box.
Oh, no, this is another R. So they're both R's.
Oh.
One is R that we got from the calculator, from the formula. And the other R is the R that we got from the calculator. From the chart. Rewind. So this is R that we got from the calculator, and this is the R that we got from the chart. But to distinguish, the R that we have from the chart is going to have a significance level. And that's that 0.01 or 0.05. And real quick, significance level is how significant, you'll learn a little bit later, how confident are we? How significant it is? Are we 99%, which is 0.01, or 95%, which is 0.05? So we'll get deeper into that later, but just know that alpha is the level of significance. So in order to compare, obviously, I have to tell you the level of significance that we're looking for because you see that the numbers are different. So what do we need to read this correlation coefficient chart? All we need is the level of significance and N. By now, from the first chapter, chapter 1, you should know N is what? Right?
Total.
Yes, the number of data points. Yep. All right, not individually, all right? We'll go back to our chart in a minute, okay? So those are the two things we need in order to find out R from this chart to compare it to this one, okay? So we got here our R, since it's already, let me go back to the screen. Here our R, since it's already positive, all right, is going to be 0.693. Now, I leave a little space here, all right, this is the formula, right, to say if that, because it could be greater than, but we know it's only statistically significant if this is greater than what you find on the chart. We good? So our R alpha in the textbook, let's reshare the screen. In the textbook, it said that 0.01 level, all right, so 0.01 level, right? So let's go to our chart and see what's up with that.
Will it always give you the level?
Yeah, it has to, yeah, because you can't do the chart without it. So 0.01 level, so 0.01 level, and how many data points did we have for this one? Now you could look in your calculator and see.
I think it was 10.
I'm going with her. Now, if you ever wanted to see, you can scroll down and you see that says, oh, I'm in line 2. I could be in line 1. Everybody see that number next to the L? All right, that tells you how many data points you have. So like she said, it was 10. Everybody good? Or you could just count them on the screen in the textbook. All right, if I go to the textbook, wherever that is, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or usually it would tell you in the problem right here, the sample size. All right, and actually, I'm gonna erase number of data points because that's gonna be confusing. N is the sample size. We wanna stay consistent. So I put sample size, I rewrote it, so take it out, because that's the language we should be using, not me making up stuff, all right? So, sample size. So we have, our sample size is 10 and we're looking for 0.01, all right? So we're looking for, this how you can write R alpha. Let me switch back for the people in Zoom, all right? So R alpha, so you write R of 0.01. That little alpha, we replace with 0.01. Question?
Wait, that's an R?
That's my R, yeah.
Okay.
Yeah, I can't make R, no matter. Stop making on my R. She called it a little box with a hook, and he's like, what letter is that?
Well, I thought it was like the square root symbol for a second.
That don't even look like square root. I mean, I can get with my jacked up R and shit, but now that, it does not look like this.
Well, I don't usually do this thing in the first.
Oh, you make the little, you make it without the hook?
Yeah.
Oh, man, I done marked that all wrong in high school. All right, so we can say no. I'd be like, what is that? Where's the hook? But yeah, so they picking on my R,
It's so,
Savannah.
it's so sharp.
Look at all y'all. All right, so so R.01. So that's what we're looking for. So let's go back to our chart and see what's going on with this situation. Ship. All right. So we go to 10. I'll be right with you. So we go to 10 and then we go to R.01. All right. And what we see is that R is equal to 0.765. Everybody go with that? All right, so 0.765. All right, so we got 0.765. You just go right over to 10. You don't need 05 if they ask you for 01. Now you see they could ask you for 05. I'm just gonna write this real quick for myself to do. 0.05. What was that, 0.632?
Yeah.
Okay, I'm just gonna write that up there for me. All right, so for R is equal to 0.765. R alpha. So minus the decimals, that's the easiest way. And you'll notice that throughout as far as rounding rules, when we have charts, the numbers that we get from the calculator that we round have to be the same number of digits that come from the chart. So you don't have to memorize that it needs to be 3 digits. When you go to look at the chart, you'll say, dang, I'm trying to compare 2 numbers and they need to be the same number of digits. Does that make sense? So if you have a chart, you already know that this has to be 3 decimal places because a chart is 3 decimal places, okay? So we're here, all right, so now I'm going to figure out, is 693 greater than, less than, equal to 765? It's less than, everybody cool? So it's less than. Now this is the rule in black. This is what actually happened. So the question is, from that, is this statistically significant?
No.
No. Savannah, Tia, that's good? It's not?
Yep.
Yeah.
So this is not statistically significant. So for our next part of the question that we had, the question is this statistically significant? The answer is no. The answer is no. This is not statistically significant. So it's something that we probably would not want to work on as statisticians. It's not important because it's not statistically significant. So I'm going to add 2 more things, which would be 2 more questions to it. So the way they had it in the book, we had A, draw the scatter plot. B, tell if it's positive or negative. C, give me the correlation. D, is it statistically significant? So this would be D. D is no. Okay, so D is no. I'm gonna add 2 more questions to that because they will be, and we're gonna talk about the correlation coefficient. Well, we already talked about R squared. All right, so I said it was in the next section, but when I looked in the book, it's actually in this question, this section. So the coefficient of determination. So R squared is the coefficient of determination. All right. So remember, all right, we're talking about a linear, R is talking about a linear relationship. All right, that's what we said. R is our linear relationship. So our linear relationship, we've already looked at. All right. Now what the coefficient of determination tells us is how much of backup. There are different things that can contribute to a relationship, to a total thing, right? So if you think about what I said in reference to teen pregnancy, it could be socioeconomic, it could be self-esteem, some people say, it could be non-education about using contraceptives, you know, it could have a whole bunch of variables, right? So what the coefficient of determination does, it measures how much of this R level is due to this correlation, is due to the correlation that we talked about. So for example, in our problem, we were talking about, and that's why it's important to have context. So we were talking about the number of bids on eBay and the price. All right, the number of bids on eBay and the price. We said that there's really no it's not statistically significant. So it doesn't really matter. It doesn't have any significance between the price and the number of bids that people put on it. And you think about it, you think it would, right? But evidently it didn't, not in this sample here, right? So that's no. So now my coefficient of determination is going to tell me what percentage, right, of the number of bids, all right, have to do with the price. What percentage of that? All right, that's what the coefficient of determination tells us. It's a measure of the proportion of variation, that's what the book says, in the response variable that can be associated with the variation in the explanatory variable. So, right? So the proportion of variation in the response variable that comes from, right, the explanatory variable. That's what it is, right? That comes from the explanatory variable. And we do put a coefficient of determination, we put that in percentages. So my question is, it might be, I don't know how it's going to be exactly worded, but in the book they say, calculate the coefficient of determination, R squared. Interpret the meaning of R squared for the given set of data. All right, so let's first do the first one. So again, I'm adding on to calculate the coefficient of determination. So this would be E, right? Calculate the coefficient of determination. All right, I ran out of space. I might have ran out of space. Oh no, I just made it. All right. So calculate the coefficient of determination. That's my E. And that's pretty simple. Let's just go back to our share screen. I'm just going back to do my test because it's right under it. All right. So you see that R squared, all right, we're going to put it in a percent, but R squared is equal to 0.480 if you was doing it. So, and it'll be a whole number. So that's 48%. Everybody see that? 48%. So R is 48%. All right. So R is 48%. Oh, sorry, R squared is 48%. R squared in this example is 48%. And I said this is E, I want to move it up because it's getting low on the board. All right. So R squared is 48%. All right. And the next question will be on the test A, B, C, D, E, F. All right. I can stop sharing the screen so you can see what I'm writing. The next question is interpret the meaning of R squared for the given data set. So interpret the meaning of R squared for whatever the given data set is. All right, so for this given data set, so that's what we want to do. So how do we interpret that? Easy interpretation, and you need to write it pretty much like this, so I'm not trying to figure out what you're doing. Now you can round it to a whole number. We just want to keep them at a whole number. That makes it much easier for you guys. Only for the coefficient of determination do we give it a percent. Only for the coefficient of determination do we give it a percent, okay? So we want to say, to interpret this, we want to say 48, that's not a 4. Look like my R, evidently. 48%, right, of the variation all right? Now we go into what we're talking about. Of the variation of, let me go back to the question. Where is that? Of Y, all right, whatever Y we're going, of price, right? So 48% of the price, right? Right, what's our price? You can just leave it in price. What I would do is just copy what they said. So 48% of the price or the selling price, right, can be associated with the variation in the number of bids.
So you have to use the word variation when you
Uh-huh.
explain each of
Yep.
them.
I'll go with that in 1 second. Let's get that down. You write it like this all the time, you get 100%, me and you don't have no problem. All right. So you're gonna say whatever the percentage in our example, 48% of the variation in price and whatever our Y value is can be associated with the variation in the number of bids, in this case, our X. Write it like that as a fill in the blank. Memorize it, fill in the blank. Y then X, you'll get it perfectly right. All right. Don't try to go off left and interpret, because then I gotta read it and figure out if that's what you're saying. And if I don't agree with what you're saying, then you get it wrong and we don't go back and forth on it, because I told you how to write it, right? So 48% of the variation of price can be associated with the variation in the number of bids, because that's what you're actually saying, right? 48% of this variation, remember there's 100%, right? 48% of this is due to the number of bids. Now, and I'm not a psychologist or a sociologist or whatever, or a business person who would be researching this, but maybe somebody else want to find out, hey, where's the other 52%? Right? Where's the 52%? Where is the rest of that coming from? We know that 48% of the price, because we're trying to figure out why is this price varying, right? We know that 48% of the variation in price is due to the number of bids. 52% of the price could be due to, I don't know, the day of the week, right? More people online during the weekend, all right? So we're trying to figure out, why is there a variation in price? It could be 16% something, 8, 9, whatever. but something is causing this, but we know that 48% of it is from the number of bits. And it's pretty low, 48% is low, so that's why we wouldn't research it, we wouldn't do anything with it mathematically. All right. So any questions? Those are all the questions as I glance through the textbook for anything like that. If we have a minute, then we will do another example, but we're gonna go to 12.2. Any questions? Let me stop it. Watch this recording come out a mess. When I post it today for you guys, I'd be like, I don't know what happened. I know what I was doing. I usually record my videos at home at my computer, you know, and then post them in YouTube. I don't do any in-class recording. But the calculator stuff is important so that you can go back to it and don't have to look up all that stuff. But anyway, we're at linear regression. So linear regression is what you may used to know in algebra, not used to know as a line of best fit. So that's what we used to call it, the line that best fits that line, that linear relationship. Now, you can find out R, you can find out R squared, and then you can find out if it's statistically significant. If it is not statistically significant like our last one, you can't find a linear regression line. So there would be no linear regression line. So the answer to is it statistically significant has to be yes for you to do the next step. Now the calculator is going to give it to you, right? But it doesn't exist. The calculator figures out numbers. Let me repeat that again. So for the last question, when we said, was it statistically significant? The answer was no. If I ask you a question after that about this linear regression portion, you cannot answer those questions because it's not statistically significant, which means it's not a linear relationship, which means we can't use it. We can't use a linear regression line, all right? But the calculator will give you the numbers. The calculator has numbers right now for a linear regression. All right, I want you to repeat that and rethink about that several times because some students will, for every one that I do, give me a linear regression line, not even looking to see if it was statistically significant or not. So the only way that you get a linear regression line is if you say, yes, it's statistically significant. If you say no, you cannot make any prediction. So what's a linear regression line? A linear regression line is used to predict what's going to happen in the future. You can't predict it if it's not linear because we don't have that kind of power. If it's parabolic, we would have to use a parabolic function, but we're talking about linear. So we need to predict it. For example, if I say during Christmas, people go and they buy, I don't know, I mean, during Valentine's Day, people buy chocolates and they buy X number of chocolates and it costs this much. So you remember that? So we buy 3 boxes of chocolate, then it's going to cost $15. And then you say, hey, how much would it cost if somebody bought 6 boxes of chocolate? So that's the linear regression line that we'll be talking about today, all right? And so it's a little bit different. So they have different forms in the textbook, I think on page 748 in the textbook that we're using, it gives you different forms of the linear regression line. Remember, this y equals mx plus b, no, that's for algebra. Again, it's the same formula, but we don't use those letters. All right, we use y equals a plus bx. That's what we use. All right, we use y equals a plus bx, which is the selection that you're going to make on your calculator. And this selection is also there. Don't get it confused. Okay? All right, so you may remember that, who said that? Oh, that was Tia, all right? Last class, she said, she gave the formula y2 minus y1, and she was going over that x2 minus x1. She gave that formula, and that formula is really for the slope, which is m here, b here, all right? Anything in front of x is a slope. So it was a slope. So that formula is actually in the textbook, and it's some long drawn out formula, all right? We're not in algebra. All right, so we're not in algebra. We won't be using that formula. We won't be figuring out. We'll let the calculator do all that for us. But just so you can see, just for kicks and giggles, right? let's take a look at the formula. So you can see what it looks like. So you see, I'm not making up stuff as far as it being another long unnecessary situation. Right? So the top one is the formula for the slope and the bottom one is the formula for the intercept. All right, those are the formulas. Again, that's what the computer had, that's what the programmer of your calculator did. They programmed that particular formula into the calculator so that it can spit out what you're going to get, so it can spit out the formula that we're looking for. And again, over here, just so you remember, it says round the slope and the intercept to 3 decimal places. So anything that you're dealing with that has to do with what we're calling R or the linear regression, you'll have to round to 3 decimal places. Okay, that's the most important thing. One of the most important things in the chapter. We'll do an example in a minute. And then I just want to, I'm not going to write all this on the board. I'm just going to go over this right here, which is important. All right, so we're going to be using this linear regression equation, right? We're going to be using this to make predictions. But in this case, this is when predictions should not be made. Number one, right? The first reason a prediction should not be made is that the data does not fall in a linear pattern. Remember, I just talked about that in the scatter plot. If it's not linear, then you can't use the equation to make a prediction because it's not linear. And the regression line is for linear models, all right? You can't do one when the correlation coefficient is not statistically significant, which I brought up, all right? If it's not statistically significant, then you can't do this. You can't make predictions about it, all right? You wish to make a prediction about a value outside of the range of the sample data. I'll tell you about that in a minute, okay? And last but not least, the population is different than from which the sample data was drawn. You won't come across that in this class where you took a data from some other population and now you're trying to make a judgment. So for example, I could take a survey, let's say, from Caucasians, right? And then I say, okay, I took this survey from Caucasians, and then I want to take that survey and then say that, well, African Americans feel like this. You can't do that because you didn't pull from that population. So you can't just assume that one population is going to be the same. Everybody follow? That's one of the reasons why we have to have a population of everybody. If we're talking about nationalities, if we're talking about sexual orientation, any of that stuff, we have to have everybody in the field because you can't make an assumption if you weren't a part of the population, all right? So like if you weren't a part of the group, all right? So that's what that is, but you won't encounter that. I encounter that often in upper level statistics courses, but you won't encounter the last one. But number 3, all right, make predictions outside of the value. So let's say our data, all right, let's go back to our data from our last problem actually. All right. So our data from our last problem, was about eBay, right, and the number of bids. So that was our data from our last problem. If you notice, we have number of bids from 1 to, what's the highest number of bids, 32? All right, from 1 to 32. So if we had a regression line, my first question is, for this problem, could we make a linear regression line? Could we make a prediction from the problem we just did? No, why not, Trevor? It's not statistically significant, so we would not do this next step that I'm talking about, all right? But let's say if we did, we see that our number of bids are between 1 and 32. So we can make an approximation. We have 1, 4, and 5. So let's say we said, hey, what would be the price if we had 28 bids? Everybody see 28's not there, right? But it's in the realm of 1 and 32. So we good, we can make a prediction about that. We can make a prediction about 35, right? It's not in the realm, but it's close. We can't make a prediction about 50 bids. Everybody follow? That's way outside of the range of the information that we use to make this line. So one of the things about making a linear regression line is that it's really about the data that you have. You can't go way outside of the data that you have. So that's what we were talking about in that box on page 751. For those of you who were following in the textbook, is that third bullet, right? That third bullet. You wish to make a prediction about a value outside the range of the sample data. So our sample data was between 1 and 32 bids. If you want to make a prediction about 50, then you have to use a whole different model or collect more data. All right. So that's what those things are. So this is important. This will be some set of multiple choice, fill in the blank, and regular work questions on an exam. So you need to understand when you can use this step and when you can make predictions. It'll be worth a lot of points because the calculator gives you the numbers. So your work in statistics mostly is interpreting and working with the data, not getting the numbers, because the numbers are given to you most of the time. All right. So let's do some video games. Let's do an example here and go through it again to make sure that we know how to do it. I'm not going to do, obviously, our example from our homework, but I will do one that helps us out and do a long one. So I'm going to take a look at, number 7. That seems good because that talks about SAT scores and something pretty cool. Stop playing around, bro. All right, so number 7. Okay, so let's take a look at this. All right. So the following table shows the average mathematics and science achievement test scores of 8th grade students from 12 countries around the world. All right. So 12 countries around the world, we don't know which countries, and not really important. Their math and science achievement scores, let's say on an SAT. Okay. So this is the information we have, and we're going to start by going through everything for this. So let me erase the board, giving you an opportunity to get that data into your calculator. And then I'm going to go through those questions that we started from, all right? And then worry about some of these questions. So I'm gonna do a full set of questions, a combination of questions from 12.1 and 12.2, and then we'll be out of here. All right, so let's get this data into our calculator. Okay, so we got all the data in from this question about the 12 countries and the math and science achievement score. We got all that data in. So before we get into predictions or whatever, I'm gonna run through the full question for both chapters, so then for both sections, so we can have this working knowledge going on with it. So the first thing that we're going to do, and I'm going to label them again, I guess A through whatever, D, whatever I had. So A is going to be draw a scatter plot.
What number on the example was this? Are you from the book?
Yes, right, in the book. I think it's number 7, number 7 in 12.2.
Thank you.
The data came from number 7. So first thing we're going to do is draw a scatter plot. So I'm going to go back to my calculator here, and go and draw a scatter plot. So we're gonna hit stat plot again. We're gonna get out of here first. And then I'm gonna hit stat plot to draw a scatter plot. No, I'm not. I'm not gonna hit stat plot people because it's already on. So you don't have to do that. You just go to graph because it's already on. You don't see a graph. You go to zoom and you go to 9. And then this should be your scatter plot. All right. You can tell if it's off or not, that's your scatter plot. I'm not going to draw it. So on the test, it might have a multiple choice and show you 4 different scatter plot drawings, and you collect the, you know, select the one that's right. Everybody cool with that? That's good.
Oh, I have a question. For the written assignments, with the draw the scatter plot, do we like just like do like a rough sketch of what this is?
Yeah, but I don't think I had you draw the scatter plot. I think I said B to D. I don't
Okay,
think.
I
don't-
wasn't sure, I didn't look at it yet.
Okay, yeah, I don't think I had you draw it. All right.
Yeah, you didn't put A.
Okay, yeah, so I didn't have you draw it. So on the exam, I won't have you draw it. But what I'll do is on the exam, there'll probably be a multiple choice with different scatter plots and you select the right one. All right. So the next thing we're going to do here is we're going to estimate the correlation coefficient. So we're going to do the correlation coefficient. Yes. Well, we're going to see if the correlation coefficient in words. So I think the thing, it says estimate the correlation in words. So estimate the correlation in words. What that means, that's why I'm writing this down, so you don't put too much on the exam. What that means is just tell me if it's positive, negative, or neither. All right. In this case, it's actually, I used the green to answer the questions. It's actually positive. Everybody good? That does look positive, right? Yeah.
Yeah,
Yeah, we going up and to the left. All right, so that's positive. All right. The next thing we want to do is we want to calculate the correlation coefficient, which is R. See? All right. Anybody got the correlation coefficient going on here?
I got 0.857.
All right. Anybody want to second that emotion?
Yeah, I got that.
All right, so we're gonna have R equals. R equals 0.857. Okay, so now we want to determine whether R is statistically significant. And I think that's a question in here because they remember they have to tell you. So we're going to determine if R is statistically significant at the point, the textbook gives us the beginning one, so let me look and see what level they're doing. 05. So 9, I mean, determine statistical significance at 0.05 level. All right, so determine statistical significance at the 0.05 level. All right, so we have R. And this is what you need to show, all right? I don't want necessarily yes or no, all right? 0.857. I need to know what it is, all right? So what's the number that we get off the chart? Somebody in here, oh, you can't see the chart. Let me pull up the chart. So somebody, one of my two people in class.
What did they ask for, a 0.01 or a point? Oh,
05,
sorry.
no problem. 05, and we had 12 countries,
0.576.
0.576, right? So 0.576 is where we're at. And this is what to that? 0.857 or 0.576, less than, greater than, equal to, whatever.
Oh, I said it's weak. It's gonna be greater than.
Is gonna be greater than. All right, so the question is this statistically significant? Yes, all right, yes, because the one you figured out from the formula is greater than the one from the chart. So the answer is yes. It is statistically significant. All right. And on this one, real quick, since we did it earlier, I will ask the question about what. I'm trying to put it all together from the last chapter and this chapter, the last section and this section. And then we'll answer the questions that they ask us in this one. The next thing is calculate the coefficient of determination. Now, I might not ask you to do all these for one problem. I might, but I don't know. All right, so calculate the coefficient of determination. Somebody got that? Tia, you got that?
No, I don't have it yet.
I got 0.735, which would be 73.5%.
Okay, but we want to leave it a whole number. So what do we want to do?
74.
Okay, would it be 74 as a whole number, actually? It would be 73, right? Because if it's 0.734, that would be 73%. You follow that?
Yeah.
All right, because you were going another digit because it was 4 digits, but it's 3. So if we're just rounding it to a whole number, it's 73%. Everybody cool with that? All right. So calculate the coefficient of determination. That's going to be 73%. Right. Then the next one is interpret the meaning of R squared for the given set of data. Okay, let me see how far. All right, so we're going to interpret the meaning of R squared for the given set of data. All right, interpret the meaning, all right, for the given set of data. How do we interpret that? We start off with what? What's the first thing we start off with, Trevor?
73%.
73%. So you always just start off to 73%. So 73%. Rachel asked us the sentence, so let's put in the sentence, 73% what?
Of the variation.
Of the variation. Uh-huh,
Of the variation. I need to see,
Yeah, I forgot the problem.
okay, no problem. Let's pull the problem back up.
whatever
So-
X is.
All
No, whatever Y is.
right, so let me pull up the problem here.
Scores, right?
73% of the variation of
Science
Scores.
score.
science scores, what are they, science scores?
Science and math,
Of
but Y.
science achievement test scores, I'm gonna put it on, science. Yeah, you wanna write it out, science achievement. I mean, it's a real sentence. Test scores. What?
70% of variations of science can be associated with.
Yes, can be associated, I wanted her to get that out. Can be associated with what?
The variation in
The variation
math test scores.
of math achievement test scores. Write it all down. Just copy what's up in the question. You will rather write too much than not enough. Because if I don't understand it, if you make some special writing that I don't understand, I'm marking it wrong, all right? I mean, I need a sentence, an English sentence. 73% of the variation of science achievement test scores can be associated with the variation of math achievement test scores. All right, that is the interpretation, that's the meaning. Let me stop sharing so that people can see what I wrote on the board. I'll say it again. 73% of the variation of science achievement test scores can be associated with the variation of math achievement test scores. That is the interpretation of this R squared that you have in E. Right? So the next ones we're going to get out of the textbook. So in the textbook, number 7, now they have questions, all right? They have actual questions. So let's go back and share that. And so let's see what the actual questions were for the problem, all right? So they told you that, A, they gave you the table, the following table, blah, 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 all right? And then B, predict the average science score for a country with an average 8th grade math score of 570. The first question is, based on our first part, can we do a prediction? Can we do a prediction? Yes. Why can we do a prediction? Because it's statistically significant. All right, it's statistically significant and it made a what? Linear line, right? It could have been statistically significant. Check it out, people. It could have been statistically significant, but it made a parabola. That's a no-go. All right. It would be an E, F, G. We're on G. So G is actually the question that's actually on the board, which is B on the board. Predict the average science score for a country with an average of 8, all that other stuff. So let's go back. Let me go back to the calculator. Let me share my full screen. So here is your equation, all right? Y equals A plus BX. Let's write out our equation back in the day. You see you have Y equals A plus BX. So this is something that we're doing. And we're just gonna copy that stuff. Make sure you put the A where the A and the BX is, all right? All right. So if you hit the linear regression number 8, you'll see this. It'll come up like this. If you hit number 4, it'll come up in the reverse order, all right? So let's do A. How are we gonna write A? Y equals, what's A gonna be? Anybody?
The number that's up there,
Well, yeah.
150, wait, do you want 4 decimal places?
Don't ask me, I'm asking you, you can't answer my question with a question. All right, they're trying to come up with it together. Anybody in Zoom land? Tia, I didn't get you on the last one, what about this one? What are we gonna write for A?
I'm 153 point, what is the data set? Did that include decimals?
Data set, I'm asking you what you writing for A.
Oh, okay, maybe a whole number, 153.
All right, are you going with 153? Going once, going twice, you going with 153 out there, Savannah?
I was gonna say 153.319, but I don't know.
153.19 will get you a check. 153 and anything less than that will get you an X. Anything with R has to be rounded to how many decimal places?
3.
3, all right? So it's 153.319 plus, now we need the B, I done spoiled everything, so I'll write this one, 0.708. I will repeat this 900 times without the decimals, it is wrong. Rounding wrong, it is wrong. So if you put 0.707, it's wrong. All right, you have to round properly and write to 3 decimal places. Let me repeat off of the screen. If you put anything, if you put 153, it's wrong. If you put 153.3, it's wrong. If you put 153.232, it's wrong. All right, if you put 153.318, it's wrong. All right, I want to make sure that you get this so that you don't get it wrong. And if you get it wrong, I will go back through here and say, if you put 0.707, it's wrong. If you put 0.71, it's wrong. Blah, 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 blah. You need to have 3 decimal places rounded appropriately, okay? So anyway, this is your linear regression line. You need your linear regression line to make a prediction. So the question asks, predict the average science score for a country with an average math score, all right? If you look at the problem, you'll know that X was the math score, all right? So X was actually the math score. And Y was the science score. Just for reference, all right? So the question is asking you, is giving you the math score, all right? It's giving you the math score. It said a student got 570 on the math score. I'm gonna share the screen again so you can take a look at the problem. So I can ask you one last question before we wrap this question up. Now, from that information, can we use a prediction with 570 as a math score? That's the question. Anybody?
Yes.
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 Everybody saying yes, perfect, yes, because it's within the data. Now, I will try to trick you. Remember, I said I want to get trick questions. I'm telling you, this would be the trick. I would say, well, if given a math score of 700, can you predict the science score? Your answer is no, because it's way out of the data range. Everybody follow me? Even though, yes, students will, obviously, you can put 700 in here and get out a number, right? Yes, there is a number, but that number has no meaning because it's outside of the data information that we have. This is within the data information. This 570 is within our data information. But if I ask you for 700, you say, I can't determine, a prediction cannot be determined, all right? So that's the only trick question, if you want to call it that, that I would ever do, because it's not really a trick question. It lets me know if you know what's up with that box and you're just not putting in whatever I give you for X, you just, excuse me, throwing it in. All right, so 570. So what is going to be the math score? Sorry, 570 is the math score. What's going to be the science score for a student who gets 570 on math? what's gonna be the science score? There's a couple ways you can do it in a calculator, but I'll let you do it the basic way in a calculator. Now, yeah, just pop it in. Now, this is not a rounding rule. This answer won't be a rounding rule, so it won't be anything 3 digits. It'll be a score, and the scores were whole numbers, just so you know. All right? All right? The scores were whole numbers, okay? So let me just share the screen again, all right? So your answer won't come back with a decimal. You're going, when do I know when to do something? It's common sense. If I'm asking for a score, the scores are whole numbers. So you're not going to give me a 3 decimal number. All right? What y'all laughing at? What'd you do?
No, I got like a really different answer, so I cleared it before she could see it.
I went to look.
Oh, she scrolled back and got it?
Yeah.
Oh, okay. So yeah, so we're gonna put this in to the calculator. And I said it was obvious, but Trevor over there screwing up something, so
Oh my
That's,
gosh, I know what
let's
I
see.
didn't put anything in for X.
So anyway, like the calculator will get, Trevor just figured out the calculator will give you an answer regardless of what craziness you put in there. So just make sure your craziness is correct. So I'm gonna put in there, we had 153. 153.319 plus 0.708 x, now you can put times or parentheses, times 570. Okay? If you give me 556.8, 0.9, I'm marking it wrong because that's not a score based on the thing. It needs to be a whole number. So what's the answer, everybody?
557.
557. All right, 557. Yep. 557.
Will it always be a whole number?
No, it'll be based on the chart. So
Okay.
remember, our chart gave us whole numbers. Let me just share our chart. See, it's not always, it's whatever the chart is. Because they asked for, you gotta remember, they asked a question. The question was, what is gonna be the score? Did they give you a chart with scores in decimals? There's no such score on that, you know what I'm saying, Savannah? There's no such
Yeah.
decimal. But if you look at number 8, could it be a decimal if we were asked for time wasted?
Yes.
Because it's a decimal. They wouldn't ask you that. They probably ask you a year for that one or whatever. So yeah, it depends on what makes common sense for that. And if you look at this one, which is probably a homework question, they gave us gas and the cost to fill up is money, so it's in 2 decimal places. So the cost would be 2 decimal places, but the miles is a whole number. We good, Savannah?
Yeah, that makes sense.
So it just depends on what the chart gives us. All right. So cool. So that's what we got here. So when we put it in, we know we have 557. So we know from, and we could look at our chart. We wouldn't necessarily do that, but we could look at our chart and see that 557 is in the range. But I mean, that's what we got. That's actually the answer. So a student who got 570, it makes sense because if you look at 585, a student that got 570 here got a 5, whatever we just said on the exam. All right, 557 on that other part. So let me write that down. 557. All right. So those are all the parts from both sections, 12.1 and 12.2. So there's nothing in here, there's nothing that's missing from these sections. Yeah, so that's all the questions that they ask on both of those sections. So you should be able to now certify in this section, and 12.1 and 12.2, you should be able to go and use your free certify. Just go there and try and certify after the lesson. You should be able to do that because we covered everything in there. So that takes care of 12.1 and 12.2. Let me start recording.
I have a question.
Huh?
You got the chart from the My Learning section for this week, right?
12.2, go into, yeah, into week 2, click on 12.2.